Okay, we're doing binomial, and this is how many ways something can happen and the probability of it happening. And the official formula is n things taken x at a time. That's the combinations. The p is the probability of success raised to the number of successes power. And the 1 minus p is the probability of failure raised to the number of failures, n minus x. And the p is pure probability multiplication rule. The probability of the first one is p. The probability of the second one is p times p. The probability of the third one is p times p times p. So you get to p to the x, and the chance of failure is just the same. 1 minus p for the first failure times 1 minus p for the second failure, and so on. The good thing is you never have to use the formula. All right, so we need XL, and we're going to look at the probability of rolling a 1 on dice. We want to roll dice 8 times. That's the sample size. And we want to know what's the probability of 3 successes in 8 rolls, which is 3 ones. So the probability of success is 1/6. This is, to find it, equals Binomial.DIST. And there are 3 parts, and it always tells you what it is. And if you get it wrong, it will say this is wrong, and you can go back and do it. We have the number of successes first. So in this case, it would be 3. The number of trials. How many times we're going to do this? Which is 8. The probability of success. And we can enter that as a decimal or a fraction. It doesn't matter how it gets in there. So it's just 1 divided by 6. The next part is whether it is cumulative or not. And if it's true, it's cumulative. You put in a 1. We don't want cumulative. We want the probability of exactly 3 successes. This is an individual probability, the probability of exactly 3. So we want a 0 there. And the probability of rolling 3 ones, exactly 3 ones in 8 tries, is 0.104. Right, so that's a probability of exactly 3. We want to do the probability of 3 or less. That's 0, 1, 2, and 3. And for that, put in a 0, 1, 2, and 3. And we're going to get the individual probabilities of 0, 1, 2, and 3. And we add them up, we get the probability of 3 or less. So next to the 0, put in equals binom. And if you forget, just start spelling it. And it's Binom.DIST. And here, we're going to do this the easy way. This is the number of successes. And here we have 0, 1, 2, and 3 successes. So instead of putting in 0, we're going to put in the cell reference for 0. And whatever you get, this one's in D5. So whatever your 0 is in, that's the cell you click. So whatever's in that cell is going to be the number of successes. Then we want 8 trials. We'll put this one in straight. The probability is 1/6 still. And we still want individual. We're going to get individual probability of exactly 0 successes, exactly 1 success, 2 and 3. And that is 0.232. We don't need more than 3, certainly. 0.233. That's the probability of exactly 0. We get no 1s in 8 rolls, which is pretty likely, given the low probability of success. We've only got a 1/6 of a chance. If you copy that formula down, and this is one of the good things about Excel, if you copy that formula down and then look at the next cell, the next calculation, it's got D6. It went from D5 to D6 because we had a cell reference, and it adjusts the cell references as you copy. There's D7, which is 2, and D3, or D8, which is 3. If we add those up, and we can do the sum of, this is a new command in Excel, SIUM, SUM, and we can do the automatic command. Mark all those 4 values, and the probability of 3 or less is 0.696. That's the sum of 0, 1, 2, and 3. If we go pick a spot, and we're going to do equals Binom.DIST, and we want 3, in 8 trials, same probability of success, but now we're going to do the cumulative probability. And put in a 1, close it, press enter, and there is the command for the cumulative probability. And it matches the one that's the sum of the individual probabilities 0, 1, 2, and 3. So if I put a 1 in there, I get 3 or less. This first one, 0.104, is exactly 3. And those two match. If I put a 1, it is how many from S on down. 3, 2, 1, and 0. This is the only way that Excel will do these things. What's the probability of 4 or more successes? I can do it individually. Get rid of that. 4, 5, 6, 7, 8. And the binomial always includes the 0 successes. So we've got 8 tries, but we have 9 possible outcomes, because we can get anything from 0 to 8. And if we take the formula that we had before, this D8, D7, D6, D5, I'm going to copy that probability of 3 down to the 8, and this is the probability of exactly 4, exactly 5, 6, 7, and 8. And these are zeros because they're very small. They're there. And if you want to look at the number of decimals, it's got 0, 0, 0, 0, on and on and on to 6. So it's pretty close to 0. But if we want the probability of 4 or more, we need to sum from 4 to 8. Four to 8. Now just take the sum, and I get 0.031. What's another way to do exactly the same thing? Shorter. I've got here the probability of 3 or less. If I want the probability of 4 or more, I have to add them up, or I can subtract 3 or less from 1. So 3 or less subtracted from 1, 0.969, gives me 0.031. The binomial will give you from a number down. It doesn't do up. And in fact, in Excel, all of the commands for distributions come from the left. They start at the lowest possible value and increase. So I can get 2 or less, 3 or less, 4 or less, but I can't get 5 or more directly. So you have to do some shifting around to get it. So either way works, and fortunately, because it's a binomial command, it's easy to do. So that's a hitch. Right? There are other commands in binomial. Pick a spot, equals bin, binom. So we cut it down. Here's the Binom.DIST. This is the one we've been using. This Binom.DIST.range will find the probability of here to here. For example, if we want 2 to 4, 2, 3, and 4 successes, we can use the range command. And we'll do that in a second. The binom.inv is confusing. It gives you the number of successes required to reach a certain threshold of probability. Right? And this is not obvious. What I just said is exactly correct, and it never made any sense to me. I literally had to graph the thing to figure out what they were talking about. So we'll get to that if we ever need it. But the binom.dist.range, choose that one. And the entries for this is the number of trials. This would be 8. Here's the probability of success, which was 1/6, and then the numbers that you want to have. And you can put in as many as you want. If I'm doing 2 to 4, I would have 2, 4. Or I could do, well, no, I don't think I can do 2, 3, 4. Maybe I can. But the number of trials is 8. The probability is still 1/6. I get a, no, didn't get a comma. Comma, and then 2 to 4. See how this works. So I'm going to get, hopefully, the 2, 3, and 4. And we can check it by adding them up. So I get 0.391. And if I add up the sum of 2, 3, and 4, That worked. I get 0.391. Same probability. So the binomial only has 3 commands. The .dist, which will give you exactly S or less, or the range, which will give you something in the middle. Right? And we could have gotten 4 or more by using 4 and 8 in this command. And it would have added those up, instead of having to subtract 3 or less. So these are the commands, and if we never get to the binom.inv, don't worry about it, because nobody else understands it either. That's the basic binomial. We're going to do another example, and this is just so you do it again and again and again. Pick a spot, 0, 1, 2, 3, 4, and 5. We're going to have 5 trials, and the probability of success is going to be 0.3. And in the old tables, we had very specific numbers. We had 0.01, 0.05, 0.1, 0.15, 0.2, so on. If you wanted 0.32, you had to interpolate in the table. Now you want 0.32, put in 0.32. So the Excel commands make this much, much simpler. We're going to get the individual probabilities for each of these things. And the easy way is equals BINOM, Binom.DIST, then get the cell reference for the 0. This one is in I3. So whatever cell you've got that's got the 0, click that cell reference. Then we want the number of trials, which in this case is 5. The probability of success, I'm going to use 0.3. And I want each of these individually. So I'm going to put in comma 0. 0 is for individual. This is the probability of exactly 0 successes in 5 trials with a probability of 0.3. 0.168. Then copy that down. This is just the easy way to do it. We used the cell reference for the 0, so when we copy this, it adjusts that cell reference on down. So this is I3, I4, I5, and so on. And I'm going to make them all 3 decimals. So there is the individual probability of 0, 1, 2, 3, 4, and 5 successes. Next to that, up here, we're going to do the cumulative version of these things, so that we have 0 or less, 1 or less, 2 or less, and so on. And this is just equals binom.dist, same command. The number of successes is still going to be the 0. We just need to click on that cell so we have the cell reference. 5 trials, comma 5, probability 0.3, and now we want the cumulative. When we get the cumulative for 0, it's the probability of 0 or less. There's no less. So it will be the same as that value right there. put in a 1, close it, and there is the probability of 0 or less successes. Copy that down, and we have a cumulative probability distribution. .168 is the probability of 0. So the .528 is the sum of 1 and 0. And if you add those two, you get that. And if you keep adding successively, you get these probabilities. And the probability of 5 or less is 1, because that's all of them. Then move over and get even with this 0. We're going to repeat the 0, 1, 2, 3, 4, and 5 with a different probability. I'm going to copy these and just put them there. Then I'm going to repeat these commands, but I'm going to use a probability of success of 0.7. This one is 0.3. This one will be 0.7. Now, in the formula, we got a p and a 1 minus p. In this one, p is 0.3, 1 minus p is 0.7. We're going to swap those, basically. Copy the first two, the individual and the cumulative, and then paste them over there. And if you look, it's adjusted the cell reference to M3. From I3, now it's M3, but I still have the 0.3 in there. I want to change the 0.3 to 0.7. And I want to change this for the cumulative as well. So this is the probability of exactly 0 successes with a probability of success of 0.7. Mark those, copy them down, and now we've got the probability of success for 0.7. Look at this one and this one. They're reversed because probability of success of 0.3, probability of failure of 0.7 is the mirror image of 0.7, probability of success, and 0.3 of probability of failure. Let's make a histogram out of these things. Go to the 0.3 probability, mark all the probabilities, and we're going to make a histogram. This is just like we did before. Insert, which brings up the charts command. We want bar charts, 2D column bar chart, and that is the histogram P equals 0.3. And I just label it so I can see it. Then go to the 0.7 probability of success column. We're going to get the histogram for that one. Insert, bar chart, 2D column, and we're going to have to move it a ways. And this one, 0.3, is the 0.7 swapped. So there are times when it's easier to do 1 minus the probability. This is like getting the probability of 4 or more before we did this, when in rolling dice. If we wanted 4 or more, the easiest thing to do is 1 minus 3 or less. And if you get into a binomial where you have 25 probabilities, the sample size is 25 and you can go from 0 to 25, sometimes it's easier to get one side of it and subtract, or to do the mirror image. And the binomial is pretty unique in this, in that it's got p, 1 minus p, and if you swap it, it's still p times 1 minus p. Binomial command, individual probabilities, cumulative probabilities, range probabilities. Binom.dist.range. And that tells you everything you ever needed to know about the binomial distribution. So if we're doing quality control, we get a batch of stuff that comes in, and we want to check it. We can't check the entire shipment. Say you're getting pistons from somewhere. You're making cars. Big truck full of pistons shows up. It's got 3,000 pistons in it. You can't go through every one. It takes too long. So you take 10 out. You have a probability of failure from looking at things in the past. So you take 10, and you have to decide how many failures you will allow in your sample of size 10. And usually it's 0 or 1. Most often it's 0. And then you test those 10 and find out if you have exceeded the probability of 1 or 0. If it's more than that, you tell them, take the truck back. We don't want this shipment. If it's within your range of tolerance, you accept the shipment and everybody's happy. And hopefully, your probability test reveals whether that's true or not. Right? And you will never know whether it's true or not until you use all 3,000 of them. Right? It's a bet. All of these things are bets. You ever go on a web page? Ever go on the same web page twice within some short period of time? And they're different. Slightly different. This is an A/B test. They don't call it that, but that's what it is. They have version A of a web page. And they want to test whether, if they put an offer in there, you are more likely to buy something. So they take exactly the same web page, except they stick this offer in on it. And they look to see how many people they got with this one versus that one. And they use a binomial. So the binomial comes up in all kinds of things. You need to be familiar with it. You never have to calculate a probability. Excel will do it. You don't even have to know the formula. But you need to know what that means. What is the probability of 3 successes or less, and what does that mean to you? Also, if the probability is less than 5, we get this tail right. If the probability is greater than 5, we get the tail left. Skewed left, skewed right. And if we do exactly 0.5, we get a nice normal distribution look.